Hi, grade 9s. This is your Unit 4 practice exam. Welcome to the end of the Unit 4. I think most people have done well in this unit. So, as always, if you have any questions, please let us know, preferably before the exam, so that we can help you out. All right, so Unit 4, linear relations. We'll go through the practice exam, and as always, the practice exam very closely models the actual unit exam. So if you do well on this, you probably will do well in the unit exam. And as with every unit, you should attempt this exam before you watch the video and look at the answer key. It'll give you a better idea of what you know and what you don't know. All right, let's go. The pattern in this table continues. Determine the expression that relates the number of triangles to the figure number. So as always with these questions, we want to look at what's the jump on both sides of the table. So it looks like it's +3 down below and +1 up top. So because there's a pattern on both sides and a consistent increase on both sides, we know that it's a linear relation. So we can use these two numbers in order to help us build an equation. So the number of triangles, t, is going to be related to what figure it is. So we always take this number here, and then we multiply it by the other variable, which is f. So it's going to be 3 times f. And then we figure out what we need to add or subtract to that. So let's just start with t equals 3f and see if we have to add anything to it. If f is 1, then 3 times f would be 3. That matches up. Okay, so if f was 2, 3 times f, 3 times 2 would be 6, and that matches up as well. So it turns out this is the entire linear equation. We don't have to add or subtract anything from it. So let's see, does anything match t equals 3f? And it does, it's A. Pattern of unit squares continues. Which equation below relates to the number of cubes? Which relates the number of cubes to the figure number. Now you can do what we did above. You can build an equation or a table of values every time if you wish, or if you're capable of just sort of figuring it out on your own, that's fine as well. So let's look at some of these. We have to relate the number of cubes, so it's going to have to be n equals something. So we know it can't be that one. So the number of cubes equals 3f plus 1. So 1 would be the value for f here. So 3 times 1 is 3 plus 1 is 4. Well, clearly there's not 4 cubes there, so that one's not going to work. Let's look at 2f minus 1. So if f is 1, 2 times 1 is 2, minus 1 is 1. Okay, so that one checks out. And let's check it on the second one here. So 2 times, f equals 2, so that'd be 4 minus 1 is 3. There's 3 cubes there. I'll check it one more time. So n equals 2f, so 2 times 3 is 6, minus 1 is 5. 1, 2, 3, 4, 5. So this one checks out. It's going to be C. Which graph represents a linear relation? Okay, well, it can't be C, because that one's got a curve. The rest of them all look to be straight lines, so those all have to be linear relations. So that is A, B, D, E, F. A, B, D, E, F. There it is, B. Next page. Which graph represents the equation y equals x minus 4? I think for these ones, the easiest thing to do, especially when it gives you y equals, just create a quick table of values. So if this is x, this is y equals x minus 4. And then let's just put some values in for x, 0, 1, 2. Doesn't matter what values you put in. Excuse me. So for the first one, y equals x is 0. So 0 minus 4, that's going to be minus 4. Okay, next one, y equals 1 minus 4. So that's going to be negative 3. 2 minus 4 is going to be negative 2. The pattern's obvious. So let's just look at these 3 points and put them on the graph. X, 0, y, negative 4. 0, negative 4. Okay, narrows it down a little bit. Can't be A. And that's pretty much it. So let's go a little further. 1 and negative 3. 1 and negative 3 is right there. So we already know it's D, but I'll just track this last point anyway. 2 and negative 2. So all 3 of those points are on D. So that's going to be D. Which table of values represents the equation y equals 3x minus 3? You could just go plug these in and see if they work for you. Or you could actually check the patterns in each one. I think I'm just going to substitute values on this one because they gave us x's and we can check the y's, right? So let's look at the first one here, okay? So if x is 3, y equals 3 times 3 is 9, minus 3 is 6. So this one fails already. Let's look at B. Okay, if x is negative 2, so 3 times negative 2 is negative 6, minus 3 more would be negative 9. That one checks out. 3 times negative 3 would be negative 9, minus 3 more would be negative 12. Okay, so now that one doesn't check out because this value, the negative 8, doesn't work. Let's check the next one. If x equals 3, it's 3 times 3 is 9, minus 3 is 6. Okay, that checks. What about 3 times, if x is 4, 3 times 4 is 12, minus 3, that checks. Let's check 5. 3 times 5 is 15, 12, and now we know, we know because it's going up by 3 every time, it's going to work out. So it's going to be C on this one. I'm not even going to bother checking D. Jeff runs at an average speed of 8 meters per second. He travels a certain distance, which we're going to call D, in t seconds. So we have to write an equation that relates D and T. So his distance is what we're looking for. We have to relate distance to time. So if his average speed is 8 meters per second, right, he's going to travel 8 meters for every second, which is 8 times the t, correct? So 8 times the t should give us the distance. So 8t is right here. And if you wanted to build a table of values for that, it's pretty easy. D, and, oh, sorry, that one should be t. T, and D equals 8t, and just see if it makes sense. So if Jeff doesn't go anywhere, if there's no time, well, 8 times 0 is 0, so that makes sense. If Jeff goes for 1 second, D is going to be 8 times 1 is 8 meters, so that makes sense. He travels 8 meters in every second, which means for 2, he should go 16, shouldn't he? So that, even if you choose to do a table of values on that one, it'll make sense based on what we know about his average speed of 8 meters a second. So that one is indeed C. Which points lie on the graph represented by 13 minus x? So we've got some points here that we can put on a graph, and all we need to do is substitute and find out which of these points would actually be on the graph. You could draw a graph, but it would take a lot of time, and it wouldn't help you all that much, I don't think. Well, it would help you, but it would just take a lot of time. So let's just make a table of values, and let's sub in some of the values that we have for x in these points. Because if these values for x give us the other one in the brackets, then we know that it's on the line. And if it doesn't, then we know it's not on the line. So let's sub in 2 and -5. Remember, the x value always comes first. 0 and 2. And now let's see if those points actually work with y equals 13 minus x. So if x is 2, y equals 13 minus 2 is 11. So does that match up with this point? No, it doesn't. So p is not on the line. If x equals -5, we've got 13 minus a negative. Remember, 13 minus a -5, so that's just going to be plus, right? So 13 plus 5 is 18. So that one does check out. That one's good. R, if 0, okay, so is 13 minus 0 equals 13. 0, 13, that checks out. And S, if x equals 2, then it's 13 minus 2 is 11. Not -11, but positive 11. So this one doesn't check out. So the 2 points that are going to be on that line are Q and R, which is B. Oftentimes, a table of values is your best way to check your answers and just sort of make sure it makes sense to you. Which line is a graph of y equals -2? So for y to equal -2, we know it's got to be a horizontal line because y is always going to be on this line right here. Sorry, that's positive 2. My mistake. -2 is what we're looking for. So it would be this line right here. No matter what your x value is, y is always -2. This would be 0, -2. This would be 1, -2. This would be -2, -2. But no matter what point you put on that graph, the y value is always going to be -2. So that is line Q, which is C. Write an equation that describes this line. Okay, now again, there are multiple ways to solve this, but I think the easiest way is just to create a quick table of values based on what we know here. So this would be x, and this would be y equals, and we don't know what it is. We're trying to figure out what the equation is, but we can tell from the graph what the points will be. So let's look at x is -1, okay, and then y is 0. Then let's go to this point here, and that is x is 0 and y is positive 1. Then we'll look at this point here, and that x is 1 and y is 2. And that should be enough information for us to figure out what's going on here. So clearly on this side, it's going up by 1. And then on this side, it's also going up by 1. So it's a linear relationship, which we knew just from the straight line. But now we can build an equation from our table of values. So it's going to be y equals Okay, it's 1 times the x, and then we got to decide, do we have to add or subtract anything? So let's just look at the first, let's look at 0, okay? So if x is 0, y equals 1 times 0 is 0, and that doesn't give us 1. So we know we have to add plus 1. Now let's check it with the other ones, okay? Let's check with the very top one. X equals -1. So it'll be 1 times -1. That's -1. Plus 1 equals 0, and that lines up with what we've got in y, so that's good. And let's check this one too. So if x is 1, y equals 1 times 1, which is 1, plus 1 is 2, and that checks out as well. So we're just going to rewrite this. Anytime you have 1x or 1n or 1 times a variable, it's just the same. It's just x, right? Or n or whatever. You don't write the 1 times part. So our equation for this one is y equals x plus 1, which is C. All right, which equation describes the graph? Exact same thing. Let's just do it the exact same way. So we don't know what y the equation is yet, but we can figure it out. So this is 0, 0 up here. This graph looks a little different because normally it would be also above the line. So all the values here are negative y's, right? Like positive y would be up this way, but they didn't show us that graph. So let's just plug in some points here. We've got x is -2, and then for this one we've got y is -5. And then for this point here we've got x is -1 and y is -4. And for this point here we've got x is 0 and y is -3. So we can see what's going on here. Okay, so this is always going up by 1, right? From -2 to -1, that's positive 1, that's plus 1, plus 1. And then on the other side, it's the exact same thing, actually. We've got -5 going -4 is plus 1, and this one's plus 1 as well. So we can start building our equation. We don't want x equals, we want y equals. So y equals, and then because it's a plus 1, I'll just put the 1 there, times x. And now we can use this. Remember, we're not done yet, but we can use this to figure out if we have to add or subtract anything. So if we just go with y equals 1x, let's look at the first x value, which is -2. So y equals 1 times -2, which is -2. -2 does not equal -5. So what are we going to do to -2 to make it equal -5? We've got to subtract 3 more. Okay? And then we always double check that to make sure that it works with the other points. So we know it works with the first point. We checked it. Let's check the second point. So if if x is -1, then 1 times -1 is -1. And then -3 more equals -4. If x is 0, then 1 times 0 is 0. 0 minus 3 is -3. So those all check out. So we'll just quick rewrite this as x minus 3. Remember, 1 times any variable is just going to be the variable. So it is x minus 3, y equals x minus 3 on this chart. They are all written in terms of x plus y or x minus y. So it's not going to look exactly the same as this. Okay, but you notice on this one, all the x's and y's are on one side, and then the numbers on another side. So why don't we just rewrite? You can do this many ways. You could rewrite all of these. You could rewrite all of those, or we can just take this one and rewrite it so that the x's and the y's are on the same side. So if we try to get the x to the other side, we've got to subtract x, and then we've got to subtract x, right? So this just cancels out. And then on the other side, we've got y minus x equals -3. Does that match up with anything? Y minus x equals -3. Nope, that doesn't match any of them. So we can rewrite this a different way if you want. Okay, I shouldn't put that there, it'll look like division. We can rewrite this a different way if we want. Okay, what if we tried it so that the 3 was positive? Okay, if we if we write it so that the 3 is positive, because these 3 here, the 3 is positive, it might get us a little closer to our number. So how are we going to swap these? Okay, I don't know if you know this trick yet, but if you got a negative on one side and you multiply everything by -1, okay, so if you multiply all the terms on the other side by -1, you can flip the signs. So basically all you're doing is flipping the signs of everything, but you just got to make sure that you do it on both sides of the equation. So -3 times -1 is going to give us a +3. Negative x times -1 is going to give us a positive x. And y times -1 is going to give us a negative y. So now we've got negative y, a positive x, and a positive 3. Let's look back up here again. This is the one. We've got a negative y, we've got a positive x, and we've got a 3. So it's going to be b. Okay, but if you didn't recognize that right away, remember, you could just rewrite the order of these, right? You could have gone, because x is positive, you can just go x minus y, because you didn't change the sign, and then the 3 stays there, and then you get the exact same thing. So it took me a couple steps to get that one right, just because I like making table of values and making equations. Another thing you could have done is you could have just substituted in, and in this case, it probably would have been quicker if, I'll just write this, substitution might be quicker on this one, right? So for instance, if I looked at the first one, if I looked at A, x plus y equals 3, well, I could check that, right? So if the x here is -1, and the y here is -4, I could have just subbed that in, right? So -1 for the x, okay, plus a -4 for the y. Does that equal 3? And it's like a question mark. Does it equal 3? -1 minus 4 equals -5. So that doesn't work, right? How about for b? X minus b is the one we know it is. So let's just try it. So let's go -1 minus -4, and does that equal 3? Question mark. Well, -1 plus, because this is a plus, right? 4 equals 3. That one checks out, so we know right away. So substitution on this one would have been much quicker, but eventually you should get to the same answer. I think the substitution on this one works a lot better, because even though this equation is the same as this equation, is the same as this equation, is the same as this equation, there's a lot of stuff that you could get wrong, I suppose, if you're rearranging all your terms in your equation. Whereas if you substitute it in there, as long as you don't make any minor math errors with your negatives, it'll be a lot quicker. And I know it's B, so I don't really have to go further, but I'll just show you what it would have been for C too. For C, we've got y minus x equals 3. So again, the y was -4 minus x, which is, in this case, -1. Does that equal 3? Well, -4, and that's a plus, right? Negative is a plus. So -4 plus 1 equals -3. So that doesn't work. And you'd find if you do D that it wouldn't work out as well. So this is probably the quicker method on a question like that. And this one was really quick. This one was really quick with the table of values, because my equation matched perfectly one of them right away. But you could have done this substitution method on this one really quickly as well, and you would have gotten the same answer. You would have gotten C. So it's up to you. Whichever one makes more sense to you is fine. Which line represents the equation y equals x plus 4? Okay, so this is another one where I would say that doing a table of values is probably quickest. So I've got an x, and I've got y equals x plus 4. Let's just make a couple points. By the way, picking 0, 1, 2 isn't something that I gleaned from the graph. I just randomly picked 0, 1, 2. I usually pick 0 because 0 is, at the origin. So usually graphs, the lines are going to be somewhat close to 0, 0, as opposed to if I started with x equals 100. If I started with x equals 100, well, this graph only goes to 6. So I'm like starting out here somewhere. So, it's best usually to start with numbers near where your lines are. Okay, so if x equals 0, then y equals 0 plus 4 is 4. 0 plus 4 is 4. If x equals 1, then it's y equals 1 plus 4 is 5, and then 2 plus 4 is 6. It's pretty easy to see what's going on here. So let's check and see if these 3 points are on one of these lines. So if I go to x0, y4, it's up there. So it can't be this line, and it can't be this line. So it's got to be either R or Q. Let's see what the next point says. Next point says 1 and 5. So there's 1 and there's 5 right there. So now it can't be R, so it has to be Q, which is D. Those ones are pretty easy to solve or figure out if you just do a quick table of values. This one, it's got a fraction, but we shouldn't be scared of fractions anymore because we did a lot of fractions in Unit 3. So which graph on this grid has the equation of y equals x divided by 4? Table of values. Okay, so let's do y equals x over 4. Now, I'm going to be a little bit smart when I pick my values here. I want to pick x's that divide nicely by 4, so I don't have to keep doing a whole bunch of fractions. So I'm going to pick 0 for one value, because I know anything, 0 divided by anything is just going to be 0. So I'll pick 0, and then I'll pick 4, because 4 divided by 4 works nicely, and I'll pick 8, because 8 divided by 4 works nicely. So I did try to kind of be smart with the numbers that I picked over here so that I didn't have fractions on this side. It's easier to plot your points if your y values aren't fractions. So let's start with the 0. Y equals 0 over 4. Well, 0 divided by 4 is just 0. Okay, so that's this point right here. Well, all the graphs go through that point, so that's not going to help us. Y equals 4 divided by 4 is 1. Okay, this one's probably going to help us a bit more. So let's go to x equals 4. 1, 2, 3, 4. And then up 1. Well, we already know it's graph Q. So that's A. Okay. And if we do the next point here, we'll find it's also on that, that line. So let's go y equals 8 divided by 4 is 2. So we're looking for 8, 2. Well, we actually can't get 8 because this is 6, 7, 8. But it would be up here around 2. So even though it's not on our graph, we can extrapolate, and that line is going to be on there as well. Okay? If I'd done -4 on this one, okay, then it should be over here. So if I look at -4 divided by 4, that's -1, right? -4 divided by 4, -1. So if we go to -4 and down to -1, it's on that same line. So no matter what points we put in this table of values, all of them are going to be on graph Q. Which graph has the equation? And we should be getting good at these by now. Okay, table of values. X, y equals x plus 2. My values, I'm just going to start, make nice easy ones. So y equals 0 plus 2 is 2. Y equals 1 plus 2 is 3. Y equals 2 plus 2 is 4. Okay, so 0 and 2 is there. So we know it's not this one, and we know it's not this one, because those lines don't pass through that point. It's got to be either P or R. Okay, so let's check. 1 and 3. So that's 1, that's 3. We already know it's P, but we could also continue and go graph 2 and 4, and that's on P as well. So that one's C. Another one, which equation graphs the line below? Let's do substitution on this one. See if it works better or quicker than a table of values. So the substitution method, y equals 2x. Okay. So let's pick one point. Let's pick this point right here, okay? So this point right here, the x value always comes first, is 0, and the y value is 2. So we're going to substitute this point into all of these equations and see which one works. So for y equals 2x, we would have y equals 2 times 0, right? Okay, so y equals 2 times 0 equals 0. So in this case, for y0, so this point right here, when we subbed in 0, did we get 2 for the y? No, we didn't. So that one doesn't work. Okay, let's check the next one. Okay, we've got y equals 2x plus 2. So in this case, it would be 2 times 0, because we're only using one point, and the x is 0. Okay, so y equals 2 times 0 plus 2, and what we get is 0 plus 2 equals 2. So for x equals 0, our result was 2, so this one checks out. So I know right away it's B. Okay? I'm going to check C, just so you get a little bit more practice with the substitution method. So let's just check C. It's not going to work out. So y equals -x plus 2. So on this one, oh dear, this one might work out. We should substitute another point. I'm glad I did this. So y equals -x plus 2, but x is 0, so that's 0 plus 2, so y equals 2, so that one checks out. And D, y equals -2x plus 2, and this one's going to work out too, right? Because we've got -2 times 0 is 0, plus 2 is 2, so this one checks out. So we are only able to get rid of A. Okay, we were only able to get rid of A, and I shouldn't have put B in there so soon, because what I didn't consider is there's lots of lines that could go through this point, right? We could have lines going this way, we got lines going this way, we could have lines going this way, but what we do know is only one equation is going to work for one line. So instead of using just one point, I need to use 2 points, because one point can be on multiple lines, but 2 points absolutely cannot be on. So this is 0, 2, and this one is 1, 0. Okay, so now we got to check this point. We checked this point, and we got 3 possibles. Now let's check this point. So we're just going to kind of do it in our heads from this point forward. So let's look at B, and let's say y equals 2x plus 2. Well, 2 times 1 is 2, okay, plus 2 is 4, okay? So, maybe I will write this down. So this is for this equation. A, or B, rather, we already got rid of A. y equals 2 times 1, okay, plus 2 equals 4. So if we plug in a 1, we get a 4, but we need to get a 0. So it actually can't be B. Okay, so let's check C. C is negative x plus 2. So y equals negative, what's the x? 1. And then plus 2. Okay, so in this case, y equals negative 1 plus 2 is going to be 1. But that's not what we're looking for, because when we have x equals 1, okay, remember the negative was from the equation, we need y to equal 0, but it equals 1 here, so that one doesn't work. So let's check D. We better hope it's D. So now we've got y equals negative 2 times 1 plus 2. So y equals negative 2 plus 2 equals 0. Did we get the right output? Yes. We input 1 for x, and we got 0 for y, so it has to be D. Okay, so eventually we got to the answer there that it was D by substituting in 2 points. Now I just want to scroll up and make sure I didn't make that mistake on another one here. Yeah, because I checked multiple points on this one, I checked multiple points on this one, and for substitution here, let's just double check this one on number 10, because I think I only put 1 point in, didn't I? Negative 4, let's check. We checked negative 4. This one didn't work, so we knew it was out right away. This one did work. B worked, C worked. Did we check D anywhere? Did I check D anywhere? I don't think I did. Okay, so that's one of the reasons we need to check our work. I'm just going to erase this for now because we already went over that and decided that was definitely one way that we could get the answer. So let's just check D here to be nice and certain. What point did we use? We used negative 4 and, negative 1 and negative 4. So let's substitute that into our equation just to make sure that that there isn't more than one line here. Okay, so x plus y equals negative 3. Let's sub in the x, so negative 1 for the x plus a negative 4 for the y. Does that equal negative 3? Negative 1 plus a negative 4 equals, that's a question mark by the way, negative 1 plus a negative 4 is negative 1 minus minus 4 rather, so that's negative 5. So this one actually didn't work out, and right away the only one that worked out was B, so we were actually in good shape on that one. But yes, you should be checking with 2 points just to make sure. It looks like I checked with 2 points on this one, and I think we're good for the rest. So important little minor little double check came in handy. Because you're doing these exams at home and you can do them on your own time, and obviously they're open book, you got enough time to double check your answers if you want. All right, which graph on this grid has the equation half x plus 2? I'm going to do a table of values. I'm going to do the x, and then I'm going to do the y equals 1/2 x plus 2. And then on this one, I'm going to be a little bit smart because my x values, I know I have to cut them in half, so I'm just going to use even numbers. Because if I have even numbers and I divide by 2, I'll get a nice whole number. I won't get any fractions over here. So that's why I picked 0, 2, and 4 on this one. Let's look at y. Y equals 1 over, by the way, this x is for the whole thing, not just for the denominator. This kind of looks like I had it for the denominator there. So this would be half x. So if x is 0, okay, 1/2 times 0 is 0 plus 2, so that's going to be, okay. If x is 2, basically it's 2 times 1/2. Well, okay, don't forget this. Okay, so it's 1/2 times x, right? But that's the same thing as 1/2 times x over 1. You can always put a variable over 1 if you want. So if x is 2, then it's really like this, right? Sub in the 2. So now we know that we can cancel, and then it just equals 1, right? 1 times 1 is 1, over 1 times 1 is 1, and 1 over 1 is just equal to 1. Okay? So if we sub in 2 here, what we get is 1 plus 2 is 3. Next one, y equals 1 over 2x. Well, y equals half of 4, right? And we can just do that in our head. Half of 4 is 2. That doesn't make sense because this is not... plus 2, right, sorry. 2 plus 2 is 4. I say that doesn't look like a linear relation, but I forgot about the plus 2. So this one's going to be 4. So we see I have a linear relation. This one goes up by 2, okay, consistently. Up by 2. This one goes up by 1 consistently. So it is a linear, so any of these could be linear, but let's check where these points are. 0 for x, where's our 0, 0, 0, 0, right there. 0 for x, and then plus 2 is right there. So we know it's not p, and we know it's not r. It can only be q or s. Let's check the next point, and we'll have an answer. X equals 2, y equals 3. Okay, so there's 2, there's 3. We know it's going to be q. Okay, and if we sub in the last one, it'll also be on the line. 4 and 4, so 4, and then up 4. There you go. It's also on q. So we only need to sub in 2 points, but I always sub in that third one just to be sure. So this one's going to be A. All right, next one. Lots of graph work in this one. You get pretty quick at doing this after a while. The graph represents a linear relation. Determine the value of y when x equals 2. Well, you don't need to do any work on this one. You just need to go to x equals 2. So where's x equals 2? It's right there. And then you got to find where it hits the line by going up or down. Well, obviously you have to go up to hit the line, and it looks like it hits it right there at y equals 4, which is c. So you don't actually have to do any work on that one. If they give you a line, and they give you either the x or the y, you can find out what the other value is going to be. They could have given us x on this one, or sorry, y on this one, and we would have been able to find the x too. So you can go backwards or forwards, as long as they give you the line and one of those values. Exact same. Okay, so this one is y equals -5. So let's go to y is -5. So that's -1, -2, -3, 4, 5. So it's here. And how am I going to get that to the line? If I'm trying to figure out the x has to be going this way. If I'm trying to figure out the y, right, I have to go either up and down to find the line. So because I have to go left or right to find the line, well, going right's not going to help me. So clearly I'm going to go over left, and that looks like it lines up with -2. So that's C. Determine another easy one. Okay, so we're trying to find the value of x, so we know we can only go this way. Y equals 1. So where's y equals 1? It's right there. Okay, and it is right on the line. Okay, so if y equals 1 is right on the line, that must mean x equals 0, because it's already there, right? I don't have to track it to the line. So that's A. That one's easy. Graph represents another easy one. Okay, y, so we know we have to go up or down. X equals 3, so let's go. Oh, we got to extrapolate on this one, because x equals 3 is actually not on our graph. But if we extrapolate and then find x equals 3, well, there's x equals 3, and we go down, what do we find? It's right about there, which is -4. So that's actually an extrapolation question because it goes outside of the graph we already have. I suppose an argument could be made. It's probably not a grade 9 argument, but I suppose an argument could be made on this that we don't know that this trend continues. So we're making an assumption that the trend continues and that would line up. I suppose it would be a reasonable conjecture, something you might see in a 30 level class, where you could make an argument that there is no answer for this question because we would have to make an assumption that the data carries on and at a consistent rate. But in grade 9, we're just going to extrapolate. A car travels at a constant speed. Okay, the graph shows how the distance of the car changes with time. Estimate the time it takes to travel 250. Okay, estimation means we're probably extrapolating here. And if we're extrapolating, we have to be able to assume that the graph continues in the same format. So it looks like this line. I'll actually use the line tool because it'll be a little bit more accurate. So it looks like this line kind of continues on like that. Hopefully I didn't mess that up too much. Yeah, that looks pretty good. Okay, so if I extrapolated this line, and I need to hit it at 250, okay, so that's 250 right at the top of the graph. And then if I had to carry this graph over, sometimes you got to draw more than one line. Okay, so let's just keep this going over. And then I'm going to draw another line because I got to go straight down, right? It looks like pretty much straight down. So if I were to continue this one over, what's the gap between that and that? It's 0.5, and it looks like it is not quite the same distance as this, so I would say it's probably, well, it's going to be closer to 5 than any of these other answers, so I guess the best estimate there would be 5. We know it can't be 4, because 4 would be right here, and, you know, we're looking at up here. We know it can't be 4.5, because then it would be right here. And we know it can't be 1, because clearly 1's over here. So 5 is, it may not even be perfect, but 5 is definitely the closest thing we have. And I think it is actually 5. So a very good estimate in that case. Short answer, show all your work, please. Okay. We're not able to give part marks, and we're not able to give feedback if you don't show your work, and it's actually built into your marks. So it's not even optional anymore. Show all your work. Complete the table of values for each linear relation. Okay, this is just plugging values in and seeing what you get out. I always think about functions and linear relations like a hopper bin. I don't know if I've showed you this before. Okay, in this case, the x's go in, okay, and y's come out. So you got to be able to plug something in for an x and get the right thing coming out the bottom. This would be the bottom. All right, so let's plug in our x's into the hopper and see what comes out the bottom. So let's plug in x for x equals 1. So 3 times 1 is 3, minus 1 is 2. Okay, 3 times 2 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 is 8. And you don't even need to do the math, right? This is plus 3, plus 3. Well, this is going to be plus 3, and this is going to be plus 3 as well. Yeah, you only have to do 2 or 3 of them and then just follow the pattern. If they're linear, then there has to be a consistent pattern of increases or decreases over here. X minus y equals 10. Okay, now you could rewrite this equation if you want in terms of y, okay, which some people might be inclined to do. I usually do. It's just the way my mind works. So x minus y equals 10. I would want to get y by itself in positive, so I'd want to bring the y to the other side. So in order to do that, I have to add y to both sides, right? And that leaves me with x equals 10 plus y, right? And then I bring the 10 to the other side because I want it to be y equals. So then I've got x minus 10 equals y. And that's the same thing as y equals x minus 10. You can write it either way. Those are exactly the same. So y equals x minus 10. So if x is 2, y is negative 8. You can just check it with the original equation if you want. So 2 minus a negative. So minus a negative is going to be plus, right? So 2 plus 8 is 10. That works out fine. So in this, it doesn't matter which, you can plug it into this equation, you can plug it into this equation, it doesn't really matter. So 4, x equals 4, so that's 4 minus 10 should be negative 6, and then does that work with this equation? It should, because these need to be the same. These need to be the same thing, just kind of written in different ways. So x minus, so 4 minus a negative is just plus, so 4 plus 6 is 10, yeah, it works. So now we've already got the trend, right? The trend is it's going up by 2 each time, so negative 4, negative 2, and then this one should be 0. You really only have to figure out, 2 of these points, and then you can fill in the rest. But just make sure, don't, because if you make a mistake on the first point and then you keep the pattern going, obviously you're making a mistake on every one. So double check it. Graph each linear equation, y equals x. Y equals x is a good one because you actually don't even really need to put labels on this, because for every box of x, it's going to be a box of y. So if x is 1, y is 1. If x is 3, y is 3. If x is, whatever that is, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. So an easy way to graph this relation would be like that. Now, it doesn't tell us that these are continuous. So if it doesn't tell you that it's continuous, it must be discrete, which means you don't join the points. Okay? You can draw as many points as you want. I mean, draw at least 3. You can draw as many points as you want on this line, on this relation, but you can't join them because we always assume they're discrete. That means dots that aren't connected by a line, unless the question specifically tells you that it's continuous. So discrete in this case, not continuous. If it tells you continuous, if it tells you that it's continuous, that's when you would join all the points with the line. Okay, x plus 5 equals 0. You can either build a table of values for this, which I usually like to do, or you can just sort of figure it out. So what plus 5 is going to equal 0? And this would be the y, right? The y would be right there. What plus 5 is going to equal 0? Negative 5 plus 5 is going to equal 0. So if y is 0, x would be negative 5, which is 1, 2, 3, 4. This would be negative 5. So that would be 1 point, right? So what happens if x equals 1? So 1 plus 5, what am I doing here? No, that'll work. I'll do a table of values anyway, just because I want to convince myself that it works all the time. So if x plus 5 equals 0, oh, what am I doing? There's no y. I'm being silly. If there's no y in the equation, we know it's going to be a vertical line. Yikes. I don't know why I stubbed a y in there. That was silly. Let's just get the 5 to the other side, right? So it's x equals, and then we've got to subtract a 5, subtract a 5. So x equals negative 5. So this point was correct. I mean, it worked. But the reason it worked is because no matter what the value of y is, that's why y does not appear in this equation, x is always going to equal negative 5, right? So we have to have all of our points lining up in a vertical line at x equals negative 5. Sorry, that was a silly lapse in error and judgment there. Okay, for this one here, it is quite similar to b in that we do not have an x in this equation. Sorry. So for this one, there is no x. So we know when y equals something, it is going to be a horizontal line. So let's just solve the equation. 2y minus 2 equals 6. Then we got to get the 2y alone. So let's add 2 to both sides, and we're left with 2y. That cancels out. Equals 8. How do we get rid of the 2 in front of the 2y? We have to divide by 2. And that leaves us with, because that cancels, y equals 4. So anywhere on y equals 4, so that's 2, and that's 4. Anywhere on y equals 4 is going to be a point on this linear relation. So it doesn't matter what x is, y is always going to equal 4. Let's go with this one. Now we've got an x and a y, so we probably should do a little bit more work on this one. So I'm going to solve this equation, or rewrite this equation in terms of y equals, and then that'll just make it easier for me to make a table of values and graph. So I started with negative 4x plus y equals negative 8. I want to get the y by itself, and I want it to be positive. Well, it's currently positive, so I don't want to move the y. I'll move the negative 4x. So if I want to get rid of the negative 4x on this side, I have to add 4x, and then whatever you do to one side, you obviously have to do to the other, right? So negative 4x plus 4x is going to equal 0. That's the whole point of that. And then we're left with a y equals negative 8 plus 4x. Now you can rewrite this. I usually do. Y equals, just don't change the signs, right? So 4x and then minus 8. Okay, so I've still got a positive 4x and I've still got a negative 8. So I didn't change the equation. I didn't change the signs. I didn't change the equation. That's important. All right, I'm just going to take this and make it a quick table of values because that's an easier way for me to graph personally. Y equals 4x minus 8. So let's just grab some values here. Excuse me. I'll grab negative 2, negative 1, 0, 1, 2. When I'm graphing, I usually like to grab 5 points instead of 3. But it's up to you as long as you do it correctly. Okay, so if x is negative 2, 4 times negative 2 is negative 8, minus 8 is 16. Oof, that's going to be a tough one to graph because I think I've only got 10 points going either way. So that might not be a great one to put on your graph. Negative 1, so 4 times negative 1 is negative 4. That's going to be 12. This one is negative 16, not positive 16. So that's, negative 4 minus 8 is negative 12. You could, negative 112. We'll do quickly today. Negative 12. And you can see the pattern already, right? We're gaining 4. So if x is 0, then we've got 4 times 0 is 0 minus 8. So we're at minus 8. So once I see this, if I see the negative 16, negative 12, I'm thinking, that's out here somewhere. I don't want to graph that. That's going to look silly. So I'm just going to add a few more points here on the positive side so that I can get my graph into this area. So 4 times 1 is 4 minus 8 is negative 4. Well, I don't really need to keep doing math, right? It's obvious that it's going up by 4 every time. So now I've got some points I can graph. Let's, probably the easiest way is to start right there and go to, right there. That's 4 points. That's plenty. So let's look here. 0 and negative 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8 down would be right there. 1 and negative 4. So there's 1. And now 1, 2, 3. That'd be negative 4 right there. 2 and 0, right? So 1, 2, and that's 0. 3, 4. So there's 0. Sorry, what's this? 1, 2, 3. 1, 2, 3, 4. So that'd be 3, 4. Okay. And that's the points I have. Yeah, I can put 4, 8 on there if you want. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 would be right there. It looks like they're all in a straight line. And I'm kind of being a bit lazy here. I should put a few more. I should put a few more points on, right? This would be 2. That'd be 4, 5, 6. 8. Just so I have some point of reference as to where these things are. 4, 6, 8. Right. So that's 3, 4, 5. That would be 6 up there. Always a good idea. I'm doing these quite quickly because I don't want to keep you on the video any longer than I need to. But when it comes to your turn, please do put some values in here. So this would be 2, 4, 6, and this would be negative 2, negative 4, negative 6, negative 8, etc. 2, 4, 6. A small plane is at a height of 4,000 meters when it starts to descend in order to land. The plane's height changes by negative 200 meters per minute. So a height change of negative 200, this means it's going down, right? Just, sometimes it helps to draw yourself a little picture, okay? So if here's the plane, okay, and the plane is going down. Well, if this is height over here and this is time, the longer the plane goes, the lower it gets. So the height's going to go down, okay, as the time goes up. Looks like a plus, but it should be a T. So just by drawing myself a graph there, I can say, well, I know that plane is going to get a lower height as it gets a higher time. The more time it spends, the more it goes down. So even just by drawing myself a little picture like that, it helps me recognize that, this is the line I care about because that's the plane traveling forward in time as it gets closer to the ground. So that might help you. Choose variables to represent the height in meters and the time in minutes. Create a table of values to show the plane's height after 5, 10, 15, and 20. When you're creating variables, keep it simple. Okay? How am I going to represent height? H. That was easy. How am I going to represent time? T. That was easy as well. So now let's make our table of values. All right, now this is going to be the time because that's the independent variable. This is the one that would typically be our x value. You can tell it's the x value because my little picture I drew, it's on the lower portion going left and right, so that's going to be time. And then the up and down is always the y, so it's going to be h equals something. Okay, now I have to, if I'm going to create a table of values, I should probably create an equation for this. Or should I create a table of values and then create the equation? Yeah, I think that's the order I want here. So let's look at time. Time, I'm going to put in 0 here. 5, it cares about 5, 10, 15, and 20. So I'm going to write over the other question a little bit here. So if time equals 0, height is going to be what? Well, if no time has passed and the plane started at 4,000 meters, well, it has to be at 4,000 meters. Okay. Now after 5 minutes, after 5 minutes, it's 5 times negative 200 because for every minute it drops 200 meters. So 5 times equals negative 1,000. Right? Now, you got to be a little careful here. This is just how much it dropped, right? That's just how much it dropped. Remember, it started at 4,000, so 4,000 minus 1,000 equals 3,000. If you see this, it makes sense, right? I started at 4,000 meters. I went for 5 minutes, and that dropped me down to 3,000 meters. And then if I drop, I could do 10, and what's 10 times negative 200? That's negative 2,000. So now this is going to be 400, or 4,000 minus 2,000, so now I'm at 2,000. The pattern continues, right? Every 5 minutes, the plane loses another 1,000 feet. So after 20 minutes, it actually hits, whoops, that's 0. After 20 minutes, it actually hits the ground. So that's a table of values, and I just use logic to figure it out. I mean, I know you guys are capable of that as well. Using the table and the patterns you see in the table, write an equation. Okay, well, this is negative 1,000 every jump, and that's consistent. And over here, we're plus 5. So this is one of those equations, and we didn't see them very often, but this is one of those equations where the left side isn't going up by 1. Okay, it's actually going up by 5. So when we make our equation, we have to take that into account. And I showed you a little trick, and this is just a reminder of that little trick. All right? So whenever we're making our equation, it's always going to start with the one on the right, h, whatever that variable is. So it's going to be h equals, and now usually it's this number times this variable, but that's only when this is up by 1. When it's up by 5, we actually have to divide 1,000, negative 1,000, by the 5. So it's actually negative 1,000 over 5, and it's a positive 5, right? T plus or minus something, and we don't know what this is yet. So let's just simplify this a little bit first. So the height is going to equal, what's negative 1,000 divided by 5? That should be negative 200, right? We're starting to recognize some numbers already. So negative 200t, which matches up nicely with this, right? Negative 200t, right? But that's not it. We also are going to have to use that 4,000 number. And what I usually do at this point, you've seen me do it multiple times on this quiz already, or on this practice exam already, is I just plug a number in and see what I need to add or subtract. I already know because it's up here, but let's just plug this into our table of values and see what we need to add or subtract to get to the right number. So if if time equals 0, okay, negative 200 times 0 is just 0. But I need to get 4,000, right? So I need to get to 4,000. So how do I get to 4,000 from 0? I have to add 4,000. Okay. Let's see if that works with our other numbers. Okay, so if time is 5, okay, negative 200 times 5, okay, so let's just try with t equals 5, okay? So when we try it with t equals 5, we've got h equals negative 200 times 5 plus 4,000. We're just testing our equation here. H equals, okay, so that was negative 200 times 5 is negative 1,000 plus 4,000 equals 3,000. Does that match up with our graph? Sure it does. Okay, if t is 5, h should be 3,000. So in this case, we know that it's going to be plus 4,000. Okay, so our final equation here is h equals negative 200t plus 4,000. Some of you may have been or may be apt enough with this stuff to look at the worded equation and go directly from the worded equation to the variable version of the equation, and that's a-okay. Okay? I told you to pick to draw a table of values, so you would definitely have to do that, but you wouldn't necessarily have to do all this work here and checking if you were confident in your ability to just make the equation based on how this reads, right? So negative 200 per minute. Well, that's negative 200 per unit of time, which is, is it minutes? Yes, minutes. And then you started at 4,000. So whatever you descended, you have to add 4,000 to in order to get the current height. So if you can go right from this to this, that's great. I don't think most people can or should, but if you can, go for it. Now we got to graph it. Okay, so let's graph it. And you know what? I can graph it just from this table of values. You only have 10 boxes, give or take, this way. But remember, as long as you're consistent on both sides of the line, whether you're going up or down, it's okay. So let's go with 0, 4,000. So if time is 0, okay, the height is going to be this one for sure. And remember, the time is this one. Okay, just like on my sort of picture up here. The time goes left and right. The height goes up and down. Okay, so at 0 time, okay, we know the height is 4,000. So let's just make this 1,000, 2,000, 3,000, 4,000. Okay, so this is 1,000, 2,000, 3,000, and this is 4,000, and that's as high as we need to go. We can ignore anything here because we can't have negative time and we can't have negative height, right? Plane, unless the plane crashes and goes into the ground. So we know it's going to be over here somewhere. We also know that it can't be down here because that would indicate a negative height. So we know it's only going to be, our data is only going to be up here. All right, so if this is t, and I'm actually going to just move that so I don't get it. Okay, this is t. Okay, so if, what do we got? 5 up to 20, all right? So that would be, 5, 10, 15, 20. So I'll make my units, every 2 boxes is 5 minutes. And it has to be consistent, right? So 2 boxes to 5, 2 boxes to 10, 2 boxes to 15, 2 boxes to 20. Now I can graph this. 0 and 4,000. Okay, there's 0, there's 4,000 right there. Maybe I'll do it in a different color. At 5 minutes, plane's at 3,000, so that's right there. At 10 minutes, plane's at 2,000, that's right there. 15 minutes, it's at 1,000. And at 20 minutes, we know it hits the ground. So, question: Do we join these points? Okay. Answer: yes, because the plane is continuously going down. It doesn't just go from 4,000 to magically 3,000. It goes 3,999, 3,998. So this is an example that it would be continuous, just because of what we can read from the problem. We know in our it's logic. You know that a plane can't just magically disappear and appear at a different height. You know it has to be going down continuously the whole time. So this one indeed would have to be joined points all the way to the ground. And it doesn't go past the ground, and it doesn't go past 4,000 meters. This is all the data we have. So this is continuous. Okay, so the plane is continuously descending at a consistent rate. Okay, so this is just, why do we know it's continuous? Just kind of applying logic and common sense to what we know about planes. What's the height of the plane after 13 minutes? Okay, now this is interpolation because it's in the graph, but it's not one of the main markers in the graph, so I have to find out where 13 minutes is. So if this is 10, this is 12 and a half, 13 is going to be right there. Okay, now does it say estimate or does it say figure out? It says what is the height of the plane. Okay, so it's actually not interpolation. Okay, no estimate, no estimate on this one. It has to be exact. If it says predict or estimate, then you're probably looking at interpolation and extrapolation. But this one, because we have an equation, we can just plug in the values. Okay, so just substitute values in for t, right? Because this is going to be t, and then we'll figure out what h is. So h equals negative 200, okay, times t plus 4,000 is our formula or our equation. H equals negative 200, and in this case, they said the time is going to be 13 minutes. Okay, 13 minutes. 13 minutes plus 4,000. Okay, keep doing our math. Okay, height is going to be equal to, what's 13 minutes times a negative 200? That's going to be negative 2,600 feet. And then plus the 4,000, which is going to leave us with a positive 1,400 feet. What is the height? Is 1,400 feet. Don't forget your units. Tired of taking marks off for units. How long does it take the plane to reach the ground? You could do the equation, or you can just look at the chart and say 20 minutes. I know it's 20 minutes, but let's plug it in anyway, okay? So h equals negative 200 t. Sorry, pen's going wonky. Negative 200 t plus 4,000. So in order for the plane to be on the ground, that's a height, right? So height equals 0. So 0 equals negative 200t plus 4,000. Okay, when we're solving an equation, we have to get the variables on one side and the numbers on the other, and we also want the variables to be positive. So in order to do that, let's add 200k or 200t to both sides. That cancels that out, right? So 0 plus 200t is just 200t equals, and then we've got 4,000 left over here. How do we turn 200t into just t? We've got to divide the whole thing by 200. Whatever we do to one side, we have to do to the other. Hopefully we're getting pretty good at this by now. That cancels out to just t, and this equals, well, it's, you knock off 2 zeros on top and bottom. What's 40 divided by 2? 20 minutes. Don't forget. And you really should get in the habit of writing sentences for word questions. Okay? The plane lands in 20 minutes. The difference between two numbers is 2. Let x and y represent the two numbers. Complete a table of values and graph it. Okay, difference. You just got to read this properly. Difference is subtraction, right? So subtraction of x minus y equals 2. So let's just do that. X minus y equals 2. All right. We could complete a table of values right there, but you know what? When I get something like this, I'm just skipping right to C. I'm writing an equation. Why would I take more time than I need to? So I need to get y by itself and positive. It is currently negative, so I'm going to bring it to the other side of the equation, right? So I'm going to add y to get rid of the minus y, and then I also have to add y to the other side. So I'm left with x, that cancels out, equals 2 plus y. Getting closer. Now I want the y by itself and positive. Okay, it's currently positive, but it's not by itself. So let's subtract 2 from both sides. That cancels. I'm left with x minus 2 equals y. And remember, you can just flip these around and write that as y equals x minus 2. You didn't change anything. Okay, these are the same. So if some people are okay with having the y on the right side, I always like to have it on the left side. So that was easy. Now it says create a table of values from 5 to 10. So this is x, and this is y equals x minus 2, right? And it says from 5 to 10. So that's 5, 6, 7, 8, 9, and 10. Let's plug in our values. Okay, 5, x is 5, minus 2 is 3, right? 6 minus 2 is 4. You see what's happening here. At this point, this should be pretty trivial. So these sides go up by 1. This side goes up by 1 these sides go up by 1. This side goes up by 1 as well. So let's plot that. We need to go up to 10 on the x. So hopefully there's 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the very end is 10, which means the middle here is 5.